Why I think C++ is still a desirable coding platform compared to Rust. Okay. I mean, this is a bold take because, I mean, you don't even get a build tool with C++. Just so you know. Not communist for starters. You're trying to bait me again. We're not getting baited. Not getting baited. When a question is made comparing compiled languages like C++ and Rust, the typical generic answer comes both are compiled languages with no/minimal runtime that lets you write whatever the machine can do. So performance will depend on your writing and not your chosen language. Interesting. Okay, I think I see where this take is going. It's very interesting. While this is largely true, there is lots of important details left that are important to be highlighted. Not without controversy, of course. Here, I will try to dive into some of those insights. Okay, so this actually seems like it's going to be a really good article because I've been wanting to see someone voice a good defense of why C++ is still good. My general take is that it's very easy to still do, well, I mean, easy is definitely a skill issue when I say this. It's still very easy to do shared mutable memory in C++ comparatively. Fair take, I think. Okay, I think. But you also get, I'm just going to continue reading, but you also get the, with C++, if you choose to use unique pointers or shared pointers, you have a runtime slowdown that effectively Rust solves at compile time. It's just easier to work with, right? It's just much, much easier to work with. So that's kind of like in my head how I kind of think about the C++ versus unique pointers are free, man. Are they free? Are they fully free? Shared pointers are not free, right? They have an atomic counter in them, correct? I didn't think, okay, we're getting conflicting answers. I didn't think unique pointers are free. I know shared pointers definitely cost something. Shared aren't. Okay. People are generally saying, I mean, I could see why unique pointers should be free because ultimately at the end of the day, long as you are semantically correct and compile, you should be able to just get rid of the unique pointer. I mean, I think that's pretty fair. So, hopefully. Unique is just a destructor thing and is deleted a move copy constructors. Okay, so it's still something, just not as much. It's low overhead. All right. Because you know it's cheaper than non-move copy constructors and all that? No, none. None's always more free than something. Even if the overhead's super small, it's still cheaper than nothing. Okay, it sounds like we're getting kind of, I would have to look it up. I don't know the exact outcome of a unique pointer, so I just know they exist. They're great. They make life really, really easy. They give you a lot of those safety features that you've always wanted. They're fairly easy to use, and bada bing, bada boom, your code's significantly safer in C++ and more managed and easier to work with the team with unique pointers. Shared pointers also are pretty neat, but I know that they come at a cost. That's my working mental model. I don't know exactly what a unique pointer does in comparison to a shared pointer, other than that shared pointer has the atomic counter and unique pointer doesn't have it. But what does it do and how does it manage it? Does the compiler completely just take out all constructs of a unique pointer and just turns it into the thing? Just hides it completely? I have no idea. Below, I took a picture from an article on ResearchGate about, in principle, both Rust and C++ are compiled languages that use 95% of the LLVM compiler infrastructure. Rust and C++ are translated into IR, intermediate representation, where most, arguably all, optimizations are made. Below, I took a picture from an article on ResearchGate about loop optimizations. Notice that in the first Clang box, no optimization is being done. Only pre-processing, macros, etc., and desugaring, e.g. lambdas, all optimizations are done in the second box, where C++ no longer exists as a language. All right, there's all this good stuff. Here's all the canonicalization passes, loop optimizations passes, poly, loop vectorized late, mid, end passes, classic late, mid, end passes. You know what I mean? Classic. It's the classic late, mid, end. It's beautiful. It's a beautiful thing. Okay. The translation layer exists between... I actually have no idea what LLVM actually does, so this all just sounds magical. I've never really studied into optimizations. I know they're quite magical. They're quite fantastic, and it's one of the few times in life where computational theory and the real world meet, and you actually can do some pretty cool stuff. I've always wanted... It's one of those, like, I've always wanted to learn X. For me, that was in that realm, right? It's always in the always wanted to learn. This translation layer exists between C++ and its respective AST abstract syntax tree as long as a logic container are not conducive to feed optimization algorithms. Most optimization logic needs to be portable, information-rich, and quasi-assembly representation where all the side effects are resolved. That is why C++ and all other languages get converted to IR, intermediate representation, before optimizations are performed. Okay. Perfect. The same logic applies to languages like Julia, Scala, and Rust. Rust adds 3 extra IR layers, HLIR, THIR, and MIR. Ooh, the trilogy. Most trilogies suck in successive lowering steps. Still, these extra layers are related to type checking and safety mechanisms, e.g. the well-known Rust borrow checker. Okay. Cool. The parenthesis here, Rust claims that there are Rust-specific optimizations done at the MIR level that will, in the future, impact performance significantly. I have found a list of such transformations, but I could not assess nor prove that the performance impact is real or just rhetorical. My post on Reddit asking for comments on the subject has also not produced any conclusive proof either way, so even the experts are on the fence on this one. I feel it was more wishful thinking on the part of the documentation writer at the time. Very interesting. One thing that I will say that I really do like about Rust and what it can do is these iterators are zero cost abstractions. When you look at like the compiled stuff when it comes to an iterator, it's pretty neat to be able to see that your filter, map, whatever can all just run inline. Like, to me, that is a really nice experience in my book. I really enjoy that because typically, like, if you're from a JavaScript language, you forget that the closure's created, the function's created, a new array is created, whereas you just get less stuff created and at zero cost for those type of things, which I think is super cool. Iterations are a huge Rust W. Exactly. I really do love that about Rust, and I feel that is like a super under-championed feature of why Rust is really cool, and it's easy-ish to write well-performing code. But this is where the similarities end. I need to recall that this publication is about low-latency trading, and as our trade-offs when deciding if something is worth it will always lean towards the item that leads to performance increases. Okay, so this is super cool. Low-latency trading requires you to be making decisions as soon as possible, so nanoseconds matter here, which I think is pretty exciting. I love this idea. If we were a company that produces web servers or web browsers, then the conclusions below would probably be a different nature. Okay, very exciting. Performance is not only instruction by instruction execution timestamping. Before one gets to the actual instructions, an entire pipeline of human and machine interactions come into play. Some of these factors will be discussed below, beginning with the safety toll. Assuming for a second that both C++ and Rust are compiled within the LLVM framework, is any of the two languages able to produce IR that leads to faster execution in all situations? Okay. Good question here. I like where this is going. I actually really enjoy like this line of article. Rust tends to be more strict than C++. It's raison d'etre. And that means more real-time checks. Although integer underflows and overflows are only checked in debug mode, memory accesses in arrays are constantly checked for bounds unless you're in unsafe mode. Oh, I did not know that. No, that makes perfect sense. That makes perfect sense. Of course it has to, right? Is that true during production too? Okay. Which defeats the purpose. Those checks alone take significant toll. They slow down the process compared to the retrospective, naturally unchecked C++ code. Yeah, but you can get unsafe. Okay, so the argument is that, yes, if you want speed to that level where including the bounds check on an array is a significant toll, right? Significant toll. Therefore, unsafe would be the answer to this question. Okay. But is that an apples-to-apples comparison? Well, yes. If you're going to list the safety of Rust compared to C++ as a pro, then it's just as fair to list the performance hit of such safety in regards to execution speed. Agreed. Great take right there. You can't list it as a positive on one side without listing the negative on the other side. I think that's a fair-ass take You can't talk about safety, safety, safety. Oh, you can't say that. That's unfair because that's not apples to apples. I could use, to pick, you just made my brain WTF with that ass take, okay? I said fair ass, okay? Fair dash ass. The ass was not dashed on the take, okay? Okay, buddy. Get me. All right, undefined behavior. C++ relies extensively on undefined behavior. I mean, the statement isn't the greatest to say out loud in your head or to write down on paper, okay? I don't think that that's like a great thing you want to really do. As an optimization enabler, oh, really? UB can make a brutal difference in many cases. Really? Okay, I gotta hear this. Rust, on the other hand, does not and cannot leave knots untied because it focuses on security. Okay, how? Show me. For example, this simple C++ snippet shows how C++'s UB can make a huge difference. In the routine NOP, which we return the results of the division of a number multiplied by 2 by 2. It seems obvious that this should result in the original number and the assembly code just moving the input argument in the EDI register into the output register EAX corroborates that. Okay. So it's able to optimize. Look at that beauty. Look at that nice beauty right there. It optimized it. Okay, cool. When was this article written? That's a great question. Because, yeah, it was written yesterday. Yesterday. All right. I want to see this. However, when you consider the edge cases, things are not so clear. What happens if you multiply 2 up by 30 by 2 and then divide by 2? What do you get? 0? Oh, negative. Yeah. Oh, yeah. That's right. 31. You get the whole negative thing. These are signed ins. Oh, yeah. They're signed ins. Divide by 2. It is this big old negative, then that. That's a big difference. Yes, it is a big difference. So why C++ ignored that possible edge case? Because signed overflow in C++ is undefined behavior, and as far as the compiler is concerned, it will never happen. Oh, I think I see. I think I totally understand what's going on here. What is the what? Okay, so this is actually a super interesting case right here. With the edge case reasoned away by the language, the compiler is free to implement that optimization. If you compile a similar function in Rust, you'll see that Rust will be unable to optimize that expression away because both signed and unsigned overflows in Rust are well defined in the language as 2's complement. This result in assembly below, where the first line, leel, the result of the multiplication by 2 is computed. In fact, it computes the value plus value instead of a value times 2. Smart. Okay, at least that's smart right there. That's a smart one right there. And then the result is, halved by shifting right. SAR. Okay. Okay. We can see what happens here. It moves this into EAX, okay? And this one does a few operations here. A little leel, a little sarl, and then a little retq, okay? Okay, again, pundits will state that you could have called one of the arithmetic wrapping functions which force the compiler to do this optimization. Well, you can do many things, but here we are measuring the effect of the compiler over 2 similar code blocks. Okay, fair. I think the statement in what he's saying, I think to re-say what he's trying to say is that you have to do more things to get the same outcome in Rust. Is that a fair statement? All right, cache locality. Just write better code. I mean, you have to do a whole extra thing to make sure that these optimizations are happening. But do you really need to take optimizations before measuring? So the reason why these things happen is, again, he's saying exactly why he's doing this, which is real-time trading, where, like, if you're trying to do 4x arbitrage, you got to be able to respond within, 500 nanoseconds might means you don't get the arbitrage. So how fast you need to respond is really, really, really important. So when you have extra instructions, it's not good. And these people do FPGAs. This is how they also lose $400 million in a few minutes, right? So bugs are really expensive in this department. We have that whole article, $400 and some million lost in like 40 minutes because of PowerPeg. The greatest named function of all time. PowerPeg gets PowerPegged. It was so beautiful. Cache locality. C++ has full unfettered access to memory by design. C, its antecessor. Is that what? I don't know this term. I don't know what an antecessor is. Well, that's not helpful. I'm getting... What you calling me, boy? I'm confused at what's happening here. Did I just get dunked on somehow? I don't even know what's going on here. What the hell's happening? All right. It seems like ancestor is supposed to be the word, but we're using some other term here. Brazil mentioned? Did we just get a Brazil? Can we get a confirmation? Confirmation? Brazil mentioned? Died by Homo erectus. My Homo erectus lasted longer than 4 hours. I am now dead. Was created with the use case of it being a low-level language, just a tad a bit above assembly. Huh? What? This is probably the video that gets me canceled. Like, out of all videos to get canceled, this might be the one. Okay, this might be the one that actually makes it happen. C++ inherit that, which makes it arguably the easiest language to code memory-intensive algorithms and data structures like hash maps, B-trees, vectors, and lists. C's pointers have a simple and intuitive meaning. This is so good. This is like I've never... Copy and pasta. Copy and paste. Put it over here. Everyone's logical jump they have to make. Oh, I put Q's? Wait, what? How did I put a Q there? There we go. Said one guy ever. That has never been the case. That is probably one of the most frequent questions I've ever had is how do pointers work? I know it's simple. Like, once you know how pointers work, you're like, that's stupid, of course. That makes perfect sense. But until you know them, they feel hard. Almost forgot to reprime it up. Well, thank you, Ryan Winchester. Flashbacks to my university. Is this an Onion article? This is shockingly not an Onion article. It's actually a really good... This is a well-ass done article for you, Pick. Allowing even junior developers to grasp and even write statements that would be extremely hard to understand in assembly. Okay, that's actually a really fair take. That's a great take right there. Is that it's not... It's not that pointers are easy. It's that their counterpart in assembly is really hard. And so the simple abstraction that C makes on top of assembly makes it great to work with. Okay, I understand that. While Rust does allow the same, it makes it very difficult to get away with it. This is true. We've read articles, we've seen examples. Unsafe Rust is hard. Again, this is by design. Rust creators do not want you to be bit twiddling, but focus on business logic first. So they made is such that accessing memory directly is painful and time consuming. Yes, we've seen this. Unsafe Rust, not simple. This means that good developers who know how to take advantage of cache/locality will have a good time implementing such algorithms and data structures with C++ and will very likely struggle with Rust for the same task. I still am not sure if I can make a doubly linked list in Rust. Okay? I'm just saying I could make a doubly linked list in JavaScript in like a minute and a half. C++ probably like 10 minutes just because I have to remember. I have to go look up. And then in Rust, it's like, I don't think I could. I don't think I could today. It might take a little while for me to do that. You know what I mean? It might take a little bit. You just DQ in the Rust list, you suck. Yeah, skill issues. No, it's C++. I did do that. It's a skill issue. It is totally a skill issue. You have to use weak pointers in C still. Do you? Yeah, thank you for this one. Yes, I've read the book Too Many Damn Lists. Anyways, we'll look at that at some point. All right, Rust mandates the use of its own compiler, Rust C. All right, hold on. Okay, let's see. Compiler choice. Rust is an offspring of the LLVM project, and so is Julia, Kotlin, and Scala. Without LLVM, Rust would not have existed. Rust mandates the use of its own compiler, Rust-C, which is a top driver for the of the LLVM stack, pretty much as Clang is for C++. C++, on the other hand, has dozens of good quality compilers available in many platforms. Okay, bold to take. Borland, anybody? Can I get a Borland? Can we get a Borland? I'm not sure. I guess for me, this doesn't make a lot of sense, but that's probably due to the environment that I work on. So maybe this isn't like a huge W for me, but maybe it's like a huge W for something else, right? There are platforms that I don't work on, maybe that is a lot easier, right? So I don't want to say, hey, it's terrible, but maybe there's something to that makes more sense. I don't know. GCC, for example, is the most ubiquitous C++ compiler today. It exists by default. Think apt install, build essentials. In every Linux distribution, GCC has a much better optimizations in specific cases like function calls we analyzed in this previous article. Oh, super cool. On Windows, it's hard to beat Microsoft's tooling, and better tooling does influence in the way you get performance optimizations done. Fair take. Not surprising that game development is almost exclusively a Windows operation, right? Fair. No one's going to argue that one. Resources available. Although the scenario is changing rapidly, the pool of engineers with C++ background is much larger than the pool of Rust developers. Also, still fair to say for now. Let's put it this way. I think would be better to be said in this state is the pool of expert C++ developers is much larger than the pool of expert Rust developers. Like I would consider myself an average Rust developer, right? I can do things, I can get things done. I can do some lifetimes. I can work out some decently performance stuff. But I wouldn't I'm a tinker. I would put myself in the tinker, category. But as far as like expert goes, I would most certainly say I am not even close to that. And then you got to consider like the entirety of the game industry, right? Like the entirety of the game industry are pretty damn good at C++, right? They are pretty damn good. And so I have never met a game developer that I'm not pretty decently impressed by, except for TJ. Calling himself a game developer while writing an engine in OCaml? Yeah, right. Not real. You know what I mean? Not real. Yeah, right. Anyways, so if I want to bet safe in the development of a new system, I have to go with C++. I think one thing that this article is super discounting is what I call the hype factor. And if I were to post a job today saying C++ position available at some prestigious company, the response would be pretty good. I'd probably get a decent amount of applications. But if I flipped that and said the same thing except Rust, I bet you my application rate would double, if not quadruple. So I do think that there is an eagerness for people to use Rust that is not present in the C++ world, right? Why leave your current job, likely doing some C++ or whatever, to go do C++ elsewhere? Whereas most people aren't working in Rust, again, proven by the fact that there's only 20 professionals currently working in Rust, and they are totally willing to jump over to do Rust, right? They're excited about it. They're excited, they're ready, they're lubed up. You know what I mean? Yeah, if you're building Chrome with C++, why leave? Exactly. You have to have a real reason to leave. The dubious benefits of safety. Ooh. When Rust is brought up in a meeting, the first pro factor is language safety. But safety against what? In many years of coding C++, very rarely I experienced a stack overflow or segmentation fault. It is literally not an issue in every code base I have worked with. Okay. We are talking about safety against hackers. The large majority of C++ applications are non-public facing, so much that the data center machines run with mitigations turned off, since there is absolutely no possibility of contact with those machines with bad actors. So hacker safety is not a concern that I, in particular, would care unless I'm coding a web server. Okay, this is actually, I could say this, there's definitely some potential, I could understand this argument. I think I'm understanding this argument right here, right? I still am kind of doubting the whole thing, but still, anecdotal evidence. But data is just the plurality of anecdotal, right? For the most part, that is a huge portion of data that you read. Is this true? Like, I don't know. I have no idea, but I can appreciate the perspective. Sample size 1, likely not data. Let's see. Or are we talking about protection against crashes? Well, don't get me started on this one. First, crashes can happen in any languages with the same frequency. I often point to this article about Princeton's unmanned vehicle team competing in 2007 DARPA's challenge as an example of how even a heavily protected, garbage-collected language such as C# can crash and burn, leaving your process unusable. It's pretty funny. It's pretty funny when you're crashing and burning and doing that. I do think that C++ is really hard I think it's harder to get right. So just saying the dubious benefits of safety, maybe there is some truth to that in the sense that once you get good enough at C++, the likelihood of you introducing a bug goes down. I can buy that. But the guarantee that there's no bug is non-present, right? You just have no idea. Right? Valgrind is great. Valgrind gives you a lot of information. 70% of all security bugs at MS are memory safety ones. Again, but this is an operating system in which everyone can access and try to take advantage of. That is a much different situation than a server in which is running some process in which no online process is attached to. Right? I get that. These are different problems trying to solve different things. Right? Sanitizers are cool too. Yeah. Yes. Closed loop versus open loop systems. Exactly. I do think that there's a lot to be said for that. What percentage of bugs are security bugs? That's another great question. 70% of security bugs are due to memory type issues. What percent of bugs are due to security? Right? It's too hard. I mean, try coding a B tree. Well, first off, coding a B tree in general is a little bit tricky. So adding a extra layer of Rust always makes it harder. You know what I mean? It is in the standard lib. You can just do B tree. This is true. All right. Let's see. Exceptions can throw a Java process back to the main and helpless on how to proceed. The process will puke an undecipherable excuse and bail out. But C++ segmentation faults is much worse, say the haters. However, seg faults can be caught with a wrapped signal trap and handled cleanly like any Java C# exception. Okay? It still leaves the same problem, which is that you don't know the state of your program and at the point in which it's the same reason why I don't like throw, right? I don't like throw as a construct in general. So I think that that's a +1 in Rust always, which is that exceptions are not handled by throwing, they're handled by returning. This is also a go thing as well, right? Errors as values just typically lead to easier reasoning about your program, because at every step you have to handle what could happen if there was an exception there. So your ability to return whatever state you were in to a reasonable state is just simply easier. Make sense? Yeah. Seg faults meaning your data is corrupt and the best choice is to cancel the process. Pretty fair. I'd say that's fair. Zig again. Very nice. I like that. Conclusion. Given that the performance benefits are either inconclusive, non-existent, or more likely negative, the safety benefits are not really that pressing for most applications. Is that really worth moving to a completely new language with its infamous long and hard learning curve as Rust? That's good to think about. I mean, I think the one problem I think we inevitably have is perception issues, right? We have anchoring bias, which means that you've heard your whole life that C++ sucks. And so when you read an article like this, it's hard to take in what this person is trying to say. Because you're trying to fit it into this view that C++ sucks, Rust is awesome, right? And so I like Rust. I would rather use I'd rather use Rust than C++, hands down. All the reasons he said are just not reasons for me, and so I wouldn't arrive to the same conclusion. I'm not concerned over whatever this case is right here, right? Like, I'm not measuring performance on an instruction base, so it's not really something for me. I like cargo. I like the fact that I can install what I need via cargo. I don't like the fact that every single project requires hundreds of little dependencies, kind of giving me this node modules feel, right? I can understand this, which is there's several learning curves when it comes to Rust, but there's also a general learning curve when it comes to C++, right? And the curve is not as fast, but does it end in the same absolute position? I am not sure. I don't know. Like, I honestly don't know if it ends in the same position. If I had been writing C++ full-time for 30 years, I'd probably just keep using that. Yeah, that's a very fair take, right? This is kind of what you have to do. Tooling makes a big difference. Also, the community is more welcoming. In C++, probably. Got him. Yeah, for new devs, what should you start learning? Probably Rust is my general take. I think C++ will give you a better understanding of memory to begin with, and actually gives you a better love for what Rust does. But then I think it's harder to understand memory and layout and things when starting with Rust, right? You can learn C. You can learn C in that. You get the same experience. It's just something to think about, you know? I do not know the general answer, but for me, for now, it is not worth it yet. I like Rust a lot. It is much more modern language than C++. No, modern C++ is not modern. It's just lipsticks on a cute pig. That's a very nice compliment to C++ you just gave there. And I truly would like to move to it eventually. However, it did not cross that threshold where I would tell a client to definitely jump on a boat. Okay. I mean, I actually don't disagree with his conclusion. I think his conclusion is actually really good. Like, when I take the perspective of what he's attempting to accomplish with the language he is choosing, it just seems like a better decision. You know what I mean? It just seems like a better decision. I get why he's doing what he's doing. Will it forever be like that? I don't know. Hold on, I like this. I like this talk. I like this thinking. I think this was really, really great. I think a lot of people don't think probably as deeply as this Henrik individual is on this. Happy about it. I mean, PhD. Okay, we got a PhD over here. I don't got a PhD. It's nuts at all. So just something to think about. Just a reminder. Ooh, nice. Let's go Netflix. Let's go Netflix. Oh, Netflix. No, come on. Let's go. Come on. Keep going north. Keep going north. Keep going north. The name. I still prefer Rustogen. I prefer Rustogen.